Okay, now we're going to take a look at doing derivatives and integrals of bases other than e. Let's start off by doing the derivative of something other than e. Now, remember, a number to the variable of x can be written as e raised to the natural log of that number. Because remember, e and that natural log of a cancel each other out, so this is just a to the x still. So when we're trying to do the derivative of something like this, we're going to use our change of base and change it to this here. Now we have it as base e. So remember, with that, we're still going to have this hanging around. Whoa, sorry about that. And then we're going to have to multiply it by the derivative of the exponent. So we're going to have the natural log of a hanging around. And then we got to multiply it by the derivative of u, which would be du over dx. But remember, this e to the ln of a is really just a, so it's just what we started out with, times the natural log of our base, times the derivative of the exponent. So just to refresh your memory and remind you that when you're doing the derivative of a base other than e, when you do your derivative, because of this little thing right here, you get the natural log of your base, your original function, all multiplied by the derivative of the exponent. Now, when you're looking at doing the derivatives of logarithms, we want to use our change of base formula to get natural log. So we go and change something like this to 1 over the natural log of a times the natural log of whatever's after the log, x. So with that in mind, we're going to use this right here. We're going to rewrite it, not do the derivative yet, just rewrite it using our change of base formula. So log base a of u is 1 over the natural log of a times the natural log of u. So to do our derivative, well, this is just a number, so that's going to still hang out in front. Natural log, so we do the derivative of natural log, so that's just 1 over what's after the log. And then we're going to multiply it by the derivative of what was after the log. That's the du over dx. So whenever you're dealing with the derivative of a log other than base e, so if it's base a, you got to go 1 over the natural log of a, multiply it by 1 over what's after your log, because that's the derivative of your natural log, then multiply it by the derivative of what's after your log. So let's go ahead then and differentiate this. It's 2 to a power, so you're going to have 2 to that power, but remember, we have to then multiply it by the derivative of our base. So we're going to have the, or not derivative, the natural log of our base. Same idea here. We're still going to have our original function, but we got to multiply it by the derivative of, or not derivative, natural log of our base, and then multiply it by the derivative of the exponent. We didn't do that over here because the derivative of our exponent was 1, so we didn't need to. So I'm going to just rewrite this a little bit, put the 3 with the natural log of 2. Could you put the 3 up as an exponent on the 2 and call it a natural log of 8? Yeah, but no big deal. Either way, it's going to work. Over here, derivative of this. Well, first of all, we got to use a change of base formula. There's no base written, so that's base 10. So we'll do natural log of 1 over the natural log of 10. And then we'll have the natural log of the cosine. So when we do our derivative, this is just a number. So we're going to have 1 over the natural log of 10. Derivative of our natural log is 1 over what's after the log, multiplied by the derivative of what's after the log, which is a negative sign. Well, let's see. That negative can come out here. Then we get sine over cosine. Oh, remember, sine over cosine is tangent. There we go. So here we have e to a power. Well, remember, e to a power is just e to that power times derivative of the exponent 1. But here we just have x to a number. So that's a situation where you want to use your power rule. Put your exponent in front, decrease your exponent by 1. So remember, in this situation, e's are numbers. Here we have a variable to a variable. When you have a variable to a variable, you want to use logarithmic differentiation. So you apply a natural log to both sides. Oh, exponent after log, put it down in front. Oh, now we can go ahead and do the product rule. So we'll do the derivative of the left side. So that's 1 over what's after the log. And then we got to go ahead and multiply it by the derivative of what's after the log. That's the y prime. So it's 1 over the y times the y prime. Over here, we do the derivative of the first. Oh, I guess I did it backwards. I'm doing the first times derivative of the second. And then I got to do derivative of the first, which is 1 times natural, or times this other one. So, hey, that's just a 1 right there. So we get y prime over y equaling just a 1 plus a natural log of x. So we got to finish getting y prime by itself, so we got to multiply both sides by y. So we multiply by y, and we get this. We don't want to leave y in our answer, so we want to go ahead and replace y with that x to the x that we started out with. So we get our derivative to be x to the x times, in parentheses, 1 plus natural log. Now we need to integrate here. So when you're integrating a number to a variable, you're going to just have that showing up. We remember your plus c. And then we have to undo. Remember, if we did the derivative, we get the natural log of 2 showing up. We're integrating, so we have to undo that. So we have to have 1 over the natural log and 2 in front. This one here, 3 times this and this here, we put the 3 in front. So now all we have to do is integrate that. So we're going to have that 3 hanging around. We remember we're going to have to undo the natural log of 5 that would show up if you did the derivative. So that's why we have 1 over the natural log of 5. We're going to still have our original function with the plus c, but we also have to undo the derivative of that exponent. Derivative of the exponent's 8, so we're going to have a 1/8 showing up. So then all we have to do is just go ahead and kind of multiply things together a little bit. 3 and 8, natural log of 5. Could you put the 8 up as an exponent of 5 on the 5 and work that out? Yes, but you need to know. We're going to use that same idea over here. However, you should know what to do on this one. Here we have an x to the negative 1. This x is in the bottom, so that's an x to the negative 2. Remember, you typically want u to be the larger exponent, so you're going to let x be, or u be that 3 over x to the negative 1. Now, if we did our derivative, we put that down in front, decrease it by 1. Oh, now we actually have this right here showing up. We don't have that negative 3 showing up, so we take the negative 3 to the other side. So what we have highlighted here matches up perfectly with that. So when we rewrite this in u's, we're going to have that negative 1/3. Then we're going to just have 7 to the u with a du for the yellow highlighted stuff. Oh, so we're going to have that negative 1/3. And we're going to then also have our 7 of that power, 7 of the u. And then we got to remember to undo what would be that natural log of 7. So we got to have 1 over natural log of 7. So we can multiply what's in front. We get this. Now, if you wanted, you could write it as one fraction. If you wanted also, you could take that 3 up as an exponent on your log. It won't make a difference.